You're going to do information on classifying triangles and angles of triangles. We're actually going to cover two different sections today, section 1 and 2, but we can handle it. So a triangle, most of you know, is made up of 3 points, and each point is called a vertex. That might be a new word, so make sure you know that word. Vertex. It's the points. And 3 segments. We call the segments sides of a triangle. So again, you know what a triangle looks like. Well, if I can get it to advance. Here we go. We've got 3 different points, A, B, C, and we have 3 segments, AB, BC, and AC. Remember, because they are line segments, we can name them in any order of their endpoints. So I could say AB, or I can say BA, either way. Okay, so sides AB, BC, and CA. And then our vertices, vertices is the plural for vertex. Our vertices are points A, B, and C. Know those words, be able to identify those parts of a triangle. Our triangle sum theorem just tells us that all of the angles in one triangle will add up to 180 degrees. You may have learned this before. You may remember it, you may have forgotten it, but from this point on, you need to know that. That is a huge piece of information that you will be expected to know from this point forward. All 3 angles of a triangle add up to 180 degrees. So this is an example. 100 plus 40 plus 40 is 180. It could be any combination as long as they add up to 180 degrees. We can classify triangles by their angle measure. One way is if all 3 angles are less than 90 degrees, which are acute angles, then we call it an acute triangle. It has to have all 3. All 3 angles have to be acute, not just one of them. If a triangle has just one right angle, which let's think about that. How many right angles could a triangle have? Could it have 2? I mean, 90 plus 90 is 180. So could it do that? Oh, but wait a minute. How many angles are in a triangle? 3. So if I had a 90 and a 90, that's only 2. So a triangle can only have one right angle. And when it does, it's called a right triangle. So know that word, that term, be able to identify it. If it has an obtuse angle, okay, something greater than 90. So you've got to know these words from the past. Obtuse means greater than 90. If it has one obtuse angle, then it would be considered an obtuse triangle. Can a triangle have more than one obtuse angle? Well, let's think about that. Let's just pick an angle size of 100 that is obtuse because that's more than 90. Could I have 2 angles that were 100 in the same triangle? What is 100 plus 100? 200, which is more than 180. So no, we cannot have more than one obtuse angle in a triangle. Okay, equiangular, equa meaning equal, angular meaning angles. Okay, so this means that all angles are congruent. So again, let's think, put on our thinking caps and figure this out. If I have 3 angles that are all congruent, so I could put these little congruency marks here, and they all have to add up to 180, what would they all have to be? They have to be the same. So, theoretically, we could just call them X. If this one's X, this one has to be X, and this one has to be X, because they're all three the same. So X plus X plus X is 3X. And those all added up have to be 180. So each one needs to be how much? I hope you said 60. Each one has to be 60 degrees. So in an equiangular triangle, all the angles are the same and they are all 60. You need to know that. We can also classify triangles by the side length. If none of the sides are the same length, all three sides have a different measure, then we call that a scalene triangle. Okay, so lots of definitions in this lesson. You need to study them, make flashcards, work with a partner somehow to learn these terms. If two of the sides are the same, notice we have congruency marks here. We can either have that or we can actually have numbers there. They would be the same. We call that an isosceles triangle. Two sides are congruent. Third type of triangle is when all three sides are the same. So let's use our reasoning skills here. If a triangle with all three angles is called equiangular, what do you suppose the name for one that has all three sides would be? All three sides are equal. It's going to be something. We call it equilateral. All sides are congruent. Again, notice our congruency marks. Or we could actually have numbers out here. They could be anything, but they all three have to be the same. Okay, so know your different types of triangles. Be able to classify them based on angles and on sides. You can classify them by both. You can have an acute scalene or a right isosceles. Okay, so be able to identify them both ways. Isosceles tend to be really common triangles that we use a lot. So they have specific labels for their parts. The two sides that are the same length are called the legs. And the side that is different is called the base. Now in this picture, the base is at the bottom where you would think a base would be. But it doesn't have to be. I could draw something like this and make these two sides congruent. This would be my base here. It's the side that is not the same as the other ones. Okay, so this would be my base. So look for these congruency marks, and that identifies your legs. The other side is your base. The angles that come off the base, okay, in the blue picture, they're down here. On the red picture, they're over here. The angles that come off the base are called base angles. And the one that's at the top, or in this picture, or that is created by the two legs, is called the vertex angle. Okay. So again, lots of new terms. That's mostly what this section, 2 sections, is about, new terms. Okay, a new theorem called the third angle theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Okay, well that should make sense to you. Here's an example. I have two triangles here. They each have a 40-degree angle, and they each have a 100-degree angle. So I have two angles that are congruent to the two other angles in the other triangle. According to this theorem, this third angle in both of them have to be the same. Why is that? How could we prove that? What did we say all three angles have to add up to be? 180. So over here I have 100 plus 40 plus x equals 180. So 140 plus x equals 180. So if I subtract 140 from both sides, I get x equals 40. Now if I do it over here, I would get the exact same situation. So therefore, in both situations, our unknown angle would have to be 40. Okay. Since they always have to add up to 180, then obviously that third angle has to be the same. Okay, so that's all that is saying. So you should be able to relate two triangles and figure out the missing parts. Okay, an exterior angle theorem. We saw that word before, exterior. Where did we see that before? Parallel lines cut by transversal. The exterior portion was on the outside of the parallel lines. So exterior angle of a triangle is going to be outside that triangle. It's as if we took one of the sides of the triangle and extended it. We just kept going. That angle that we create is an exterior angle. I could do it on this side as well. And I could do it on this side. Right? This would be an exterior angle. We could even do it on, let's see if I can erase this, the other direction. I could extend it this way, and this would be an exterior angle. Okay. I could extend this one this way, and this would be an exterior angle, and I could extend this side downward, and that would be an exterior angle. So anytime you extend a side of a triangle so that it goes beyond the triangle, you create what's called an exterior or outside angle. If you go across from that to the other side of your triangle, the angles that are over on that side are called the remote interior. Think about a remote control. It allows you to change the TV channel when you're far away. Okay? And interior means inside. So they're inside angles that are farthest away from that exterior angle. Okay, so you need to be able to identify those, know those two terms. What does that have to do with this theorem? Well, this theorem tells us that the measure of an exterior angle, this 75 here, equals the sum. What does that mean we're doing? Adding to the sum of the measures of the two remote interior angles. What is 35 plus 40? It is 75. So when you add these two up, you're going to get the same answer as what that exterior angle is. It's not this one. Do not use this angle here at all. You might use it to find one of these, but it's not going to be in your comparison. Okay? So the sum of the remote interior angles is equal to the exterior angle. Be able to use that to find missing parts. Okay, so why is that? If I have two remote interior angles here, I look at their sum, it's 75. So what is this third angle got to be right here? They have to add up to how much? They have to add up to 180. So I have 75 plus some number has to equal 180. So what is x? 105. Okay, now let's go down to this other triangle down here. Same triangle, so I know that this is 105 degrees right here. What would be this exterior angle right here? If it makes a straight line with that 105 degrees, how many degrees are in a straight line? Oh, that's right. It's also got 180 degrees. So I know that this 105 plus my unknown angle there is got to be 180. If I subtract those, then my unknown angle has to be 75. Well, guess what? That's the same as my remote interior angles up here. Okay. So if you just think it through and use the relationships that we've learned in the past, then a lot of these rules should be some common sense. Some other things that should be common sense now that you know these rules. Okay, things that they're called corollaries, statements that can be easily proved using a theorem. So we learned these theorems. Now here's some things that you should just automatically know. We've already talked about this. Each angle of an equal angular triangle has to be 60 degrees. By definition, equal angular means that all three are the same. Since they add up to 180, the only number that you can add 3 of and get 180 is 60. Okay, we already talked about this. In a triangle, there can be at most one right angle or obtuse angle. You cannot have more than one 90-degree angle. You cannot have more than 100-degree angle and still add up to 180 degrees. And the last thing, we didn't really talk about this, the acute angles of a right triangle are complementary. What does that word mean again? Dadgum. We did that a long time ago. What does that mean? Means that they add up to 90 degrees. Okay, so let's see why this should be common sense to us now. Let's draw it out. Here's our right triangle. Kinda. This is 90 degrees right here. My definition of right angle. So what we're saying is that these two acute angles here have to add up to 90 degrees. Because 90, we'll call this x, we'll call this one y, plus x plus y has to equal how much? All three angles of a triangle add up to 180. If I subtract the 90, then my two angles that are left together have to equal 90 degrees. So they have to be complementary. All right, let's use some of these rules that we just learned. The frame of this window design is made up of many triangles. Classify triangle A, B, C. Is it acute, equiangular, obtuse, or right? Well, since this is a rectangle, then this whole big angle A is a right angle. So this part inside this triangle can't be a right angle. Same thing here. So it can't be right. Nothing is bigger than 90. It can't be obtuse. So that leaves us acute or equiangular. And we haven't been told that all three of these angles are the same. So the only logical answer would be acute. The frame, same thing, but this time we are classifying triangle ACD. This big triangle over here. Okay, so we're just kind of classifying this by looks. And it looks to me like this angle right here is leaning back farther than 90 degrees. So it would be obtuse. Because it has one obtuse angle, we would call it an obtuse triangle. Identify the isosceles triangles in this figure. If And get in the habit of marking up what you're told. Okay, mark that in your picture. So UV, VX, and UX are all congruent to each other. So right there you have an isosceles, you actually have an equilateral triangle, but as long as two of them are congruent, that would also be considered an isosceles triangle. So UVX, and then see these congruency marks here? That tells us that this triangle, TUX, is also isosceles, TUX. So we have two different isosceles triangles in there. Find missing values. Find D and the measure of each side of an equilateral triangle. Okay, so we got to draw this. Okay, when you're just given a bunch of words, get in the habit of drawing a picture so you can see it. K, L, M. Okay, KL is D plus 2. LM, 12 minus D. And KM is 4D minus 13. We want to find D and then the measure of each one of these sides. Okay, well, what is the relationship between these sides that have the D's in them? If it's key word here, equilateral, means they're all three the same. I can take any two of these sides and make them equal to each other. If they're the same, they're equal. I tend to go with the ones that have the least amount or the smaller numbers or whatever. Here's a D and a 1D. So I'm going to set those two. It does not matter. I could sit here and do all three different possible pairs, but I'm not going to do that for time's sake. Okay, I'm going to get all my D's on the left. So I got to add a D, add a D. 1D plus 1D is 2D. Those cancel. Now I got to get rid of that number that's next to my D's. So 2D equals 10. D equals 5 if I divide both sides by 2. That's only part of my answer. Remember, go back to your question and make sure you are answering the question. I need to know the measure of each side. So I've got to plug it in here. D plus 2 is going to be 5 plus 2, which is 7. 7. 12 minus D is 12 minus 5, 7. Okay, do I really need to go through all this? Why don't I need to do this last one? What should I already know about the size of this side? What should its length be if it's equilateral? It should be 7. I can check myself just to make sure I haven't made a mistake. 4 times 5 minus 13 is 20 minus 13, which is 7. Okay. Find the measures of the sides of triangle RST and classify the triangle by sides. So we need to know if this is equilateral, isosceles, or scaling. So we need to know the length of each side. You can plug it in your distance formula, or remember, we can make a right triangle. You can make a right triangle with each one of these vertices and do a squared plus b squared equals c squared. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so 5 squared plus 7 squared equals c squared. 25 plus 49 equals c squared. That's a 9. So that's what? 74 equals c squared. So the square root of 74 equals c. Let's do that with the other two. So here I'm going to make a right triangle. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this time I have 4 squared plus 5 squared obviously is not going to be the same length. Let's see, how about this bottom side here? I need to go, whoops, let's erase this here. Go across here, down, so we have 2 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9 squared. Well, that's 81, and 4, definitely not the same as the other two. Any one of the other two is equals c squared. So all three of them came out differently, therefore it would be a scalene triangle. So you've got to be able to use your coordinates, coordinate geometry. Find the missing angles here. Okay, 1, 2, 3. How are we going to do that? We need to look at what is given to us. Figure out the relationships there. Well, look, I have 2 angles in this triangle. And I know that all 3 of them must add up to how much again? 43 plus 74 plus, we'll call this angle X, Y, and Z, just so we don't have numbers in here. They must add up to 180. So I add my 2 here, the 2 known angles, and I must subtract that from my 180. So X equals 63. Now I'll look at this triangle on the right here. I don't have 2 angles to solve for the third one. So that means I've got to look for another relationship. I always have to ask myself, what are some relationships here that I can use? What do I know about this picture? Well, angle 1 and 2 are what we call vertical angles. How are vertical angles related in their size? Again, that goes way back. You got to remember this stuff from chapter to chapter. So angle 1, or angle X, we'll call it, is going to be equal to angle Y. So angle Y equals 63 also. Now, how am I going to find angle Z? Think about it, think about it, think about it. I'm going to add them all 3 up and make them equal to 180. Okay, so 12, 7 and 7 is 14, plus my X. If I subtract that from 180, I get 38. So my 3, whoops, and that was actually Z. Not to confuse you. Sorry about that. I'm just in the habit of calling my unknown X. So angle X is 63 degrees. Angle Y is also 63 degrees. And angle Z is 38. Okay? This would be done the exact same way. So I'm not going to spend time doing that. You can go back and try it yourself. Exterior angles. Find the measure of each numbered angle in the figures. Okay, so again, lots of relationships here, lots of triangles. I see 1, 2, 3, 4, and then this big triangle 5, and this big triangle 6 different triangles. So where to start? What are we going to do to figure out any of these unknowns? Well, I have an exterior angle here that is exterior to this triangle right here. And I learned that that exterior angle is equal to the 2 remote interior angles. So angle 1 is going to be equal to 32 plus 38, which is 70 degrees. If I know angle 1 is 70, I can find angle 2 because they make a straight line. Anytime you have adjacent angles that make a straight line, you know that they add up to how much is a straight line? This is an angle sign. 180. Now I can plug in my 70 for angle 1. Whoops. Plus angle 2 equals 180. So angle 2, if I subtract the 70, is 110. Okay, so that helps a little bit. Oh, now, where do we go from there? Well, angle 2, let me clear this out a little bit so we can see it better. Angle 2 here is an exterior angle to this small triangle. If it's 110 degrees, put the 70 back in. It's the sum of these two angles. So 64 plus angle 3 is going to equal 110. So angle 3 is going to equal, what would that be? 46. Okay. And we just build from there. I know this has been a long segment, so I think we'll stop there. Just gives you kind of an idea of how to use one relationship to find another, to find another, to find another. Okay. We can go on and finish this one out so you don't leave you hanging. To find angle 5, see, I don't always have to go in order. I'm going to use this big triangle here because I have the 38 and I have this angle down here. So 38 plus my 41 plus 64 plus my angle 5 is going to equal 180 degrees. So here's 105, which would be 143 plus angle 5 equals 180. If I subtract my 143, then angle 5 equals 37. And then the last one I'm going to find is angle 4 by using, okay, remember that, 37 degrees. I'm going to erase all this. Okay, this was 37. So to find angle 4, I'm going to use this smaller triangle here. 37 plus 41 plus that angle 4 is going to equal 180. 78 plus angle 4 equals 180. So angle 4 would equal 102 degrees. All right, so that is it for today. I'm going to leave this one to you to figure out. The flower bed shown is the shape of a right triangle. Find angle A. That should be super easy for you to do now that you have had plenty of experience adding up all three angles to 180 degrees. Okay, until next time.